Alright, so picking up in chapter 1.2c, our properties of radicals, we're going to talk about when we're simplifying these radicals. Alright, so basically when we're simplifying a radical, we want to make sure that every factor underneath the radical is actually factored and that there's no exponent greater than the index. Okay, so number two, pay attention to it because you can't have a radicand with a fraction, but yet you can have a radicand in the numerator or the denominator. It's just the entire expression can't be a fraction underneath the radicand. Okay, so the denominator cannot contain a radical unless you're only asked to evaluate the numerator. And basically what number 4 is saying is that if you have a variable raised to a power, that power cannot be greater than the index. Alright, so if we look at a couple of examples, this first one we need to evaluate the cube root of negative 16 x to the 8th power y to the 4th. Alright, and so I'm going to show you two different ways of looking at this and then you decide which way works best for you. Okay, so first way we're going to look at is that if I just prime factor this out. Alright, so because this is negative and this is odd, I know that this can happen. Just remember whatever term I decide to pull out of this, it attaches, that negative 1 is going to attach when I bring it out. So really I have the cube root, and so if you think of 16, that's just 2 times 2 times 2 times 2. X to the 8th is just 8 x's, x times x times x times x times x times x times x. And you're probably seeing like this can take a while writing this all out, but this is like the best way for you to see it. Now because I know that this is negative, I'm going to just take negative 1 times whatever else I can pull out of here. So this index tells me the grouping that I'm going to look for. So I'm looking for groups of 3 of the same term. So I have 3 2's. I have 3 x's, I have 3 x's, I have 3 y's. Right? So basically I have the cube root of 8, which is just 2, times the cube root of x to the 6, which is just x squared, times the cube root of y cubed, which is just y. Right? So by pulling that all out, my coefficient becomes negative 2x squared y, and what I don't touch I put back underneath the radical. Right? So I have 2 times x squared times y. So I have 2x squared y, and now I would be simplified. This would be my solution. Alright, so another way of evaluating these is when we look at this. So again, if my index is not present, it's assumed that that's a 2. And so another way I can look at this is I can say, well, what is my biggest power? What is my biggest perfect square in 8? And that's just 4 times the square root of z to the 6 times the square root of the 2, right? Because 4 times 2 is going to give me my 8. So here, let me rewrite this so I'm not confusing you. So 8 is really 4, the square root of 4 times the square root of 2 times the square root of z to the 6, right? And just so you can see that the square root of 4 times the square root of 8 is the same, if I put that on my calculator, the square root of 8 and then the square root of 4 times the square root of 2, I'm going to get the same decimal. Right? So these are exactly the same. Okay? So the square root of 4 is 2 times the square root of 2. Well, that's actually rational, so I'm going to just leave it. Times the square root of z to the 6th power. So another way of writing this, so we didn't cover our exponent properties in this chapter. Right? And the next chapter we're going to talk about a little bit of going from radical to exponential form. But, we can always, anytime you have a index and you have a power, you can rewrite this. So if I had the nth root of a in radical form exponentially, and let's just say this is a to the m power, exponentially this would just be a m over n, right? So if I'm looking at this, this is really saying z to the 6 divided by 2, which is just times z cubed. So my simplified answer for this would be 2z cubed square root of 2. Alright. And so again, look at the first way we did it, look at the second way of doing it, and you decide which way is working best for you. Alright, and then finally, if we look at C, so we have the cube root of 72. So it's the cube root. So 72 has a perfect cube of 8. So really this is the cube root of 8 times 9 times x over the cube root of y times y times y. Cube root of 8 is 2. Can't do anything with the 9 or the x's, so it's 2 cube root of 9x squared. And the cube root of y to the third power is just y. And so I no longer have a fraction underneath my radicand like I started off with, but I do have a radicand in my numerator, but this is perfectly fine. So this was, when I was reading number 2, I said just pay attention to that. This is exactly what we was talking about. Alright, so again, hopefully, doing these couple of examples, you're able to see in which a way that makes the most sense to you, and you can go back and start looking at rationalizing your radical expressions. Alright, so a couple other things is, now we're going to talk about simplifying and combining radical expressions. So let A and B represent constants, variables, or more complicated algebraic expressions. The letters N and M represent natural numbers, which means we won't have any negatives, we won't have any zeros, and assume all the expressions are defined and are all real numbers. So we have these properties, right? And these properties are just like your exponent properties. Okay, same thing with your radicals. So make sure you go through these. Main thing I want you to pay attention to is that anytime you have an even index and your output is an odd power, you need to make sure you have your absolute value bars, because the fourth root of x to the fourth is x to the imaginary 1, which is odd. So you have to make sure that this solution is positive, because we won't be able to go the other way. Alright, we won't be able to prove it. And so if we are looking at simplifying these radical expressions, right? And so remember, we can't have a radical in the denominator unless we're rationalizing the numerator. So basically, we can just, since this is just root x, we can just multiply it by root x. Whatever you do in the numerator or denominator, you have to do in the numerator, right? So this just becomes the square root of x over the square root of x squared. Well, x squared can be evaluated to the square root of x over x. And now we're done. And you can't simplify, because the square root of x is not the same as x, right? And if you want to check it, just give x a value. If we said x was 4, the square root of 4 is not the same as 4. So this answer would be 2 over 4, which would just be a half. Alright, so if we're looking at this next one, here is why doing by doing prime factorization for these, it makes this a lot easier to see as you're doing this, right? So if we wrote this all out, so we're looking for the fifth root, right? So since this is a negative 1, I'm going to just pull that out in my numerator. And this is going to be over the fifth root right? And if this is confusing you, just go back a page to your properties and look at when you have a fraction underneath the radical, okay? And so this is really saying 2 times 2 times x times x times x times x times x times x, right? 6 x's. And then 2 times 2 times 2. And I'm going to just give myself space and you'll see why here in a second. Times y times y. Alright, so if I look up top, I have 5 x's that I can pull out, right? Because my index is a 5, so I'm looking for a group of 5. So I'm going to pull those out. And now really I have negative x on the outside. So my 1 is going to eventually go away because I have a variable now. Right? So my numerator, all I have left is 2 times 2 times x, which I can't do anything with right now. So my denominator needs to be rationalized. And so I have the 5th root, but only have 3 2's. So if I just multiply this by 2 more 2's, and multiply this by 3 more y's, and remember, whatever I do in the denominator, I need to do in the numerator. So 2 more 2's, 3 y's. Extend out my radical symbol. Right? Now I can see that I have 5 2's, so the 5th root of 32 is going to be 2, and the 5th root of y to the 5th power is y. So basically I just multiplied this numerator and denominator by, I just said times the 5th root of 4y cubed. And I did that down here. I said multiply this by the 5th root of 4y cubed, so I can now rationalize that denominator. Right? So this, when this is all said and done, my final answer is going to be negative x 5th root of 16x y to the 3rd, and that's all over 5y. And we're done. Okay, despite the nasty handwriting, that's an X. Alright, now, anytime we have an expression, okay, we have radicals, we have an operator in between the radicals, we have to introduce ourselves to the conjugate, or reintroduce ourselves, because hopefully you are familiar with the conjugate. And all the conjugate says is just go the opposite of your operator, right? So since this is the square root of 7 plus the square root of 3, the conjugate is just going to be the square root of 7 minus the square root of 3. Right? So if I have 4 over the square root of 7 plus the square root of 3, well, I'm going to just multiply this by the square root of 7 minus the square root of 3. Whatever I do in the numerator, I do in the denominator, and vice versa. Right? So this is basically my difference of squares. Right? So hopefully, you know, those Algebra 99 concepts are you're remembering those. So this basically says I'm just going to take my first term and square it. Whoa, that should be a 7. Take my first term and square it. And it's the difference of squares minus my second term squared. Right? And so again, if the index is the same as the power, these basically cancel. So I really just have 7 minus 3, which is 4. So this is just distributing, right? But I'm not going to distribute the 4 because I have a 4 in the denominator. So right now I have 4 times the square root of 7 minus the square root of 3, and that's all over 4. And I can just cancel my 4's. And my final answer is just the square root of 7 minus the square root of 3. All done. Alright, so looking at this last question. And for this one, let's just rationalize the numerator this time, because you will be asked to sometimes rationalize the numerator. So anytime you're asked to rationalize, it just means you can't have a radical. Right? So if we can't have a radical in the numerator, so we have negative square root of 5x. And that's all over 5 minus root x. And so I'm going to just multiply this by square root of 5x. And this is going to be multiplied by the square root of 5x. So this is going to equal negative 25x squared, the square root of that, I'm sorry, which is going to just be negative 5x in my numerator. It's rationalized now. And that's going to be over, well, if I just distribute this, I have 5 root 5x minus x root 5, right? Because the square root of x times the square root of 5x is the square root of 5x squared. My x squared can be rational, it can be simplified, and that's how I'm getting x root 5. Alright, now if I was asked to rationalize the denominator, then I would just multiply the top and bottom by the conjugate. So this would be 5 plus root x, 5 plus root x. Alright, last but not least is the errors that are made. You know, and just like our properties of exponents, there will be errors made with our properties of radicals. Okay, so we got to make sure that, you know, we don't rewrite the square root of a plus b as the square root of a plus the square root of b. That's not true. Alright, so the square root of 9 plus 16 is actually going to be 5 because 9 plus 16 is 25. Right? But not if we separate these, the square root of 9 is 3, the square root of 16 is 4, which is giving us a different answer of 7. Right? So just remember that. And other than that, hopefully now you are able to go ahead and get started in 12.C3. If you're still having issues, make sure you watch the video on the practice problems being done and performed. Talk to you soon.